Yeah, extrapolation. There's one other new thing.
Interpolation.
Correlation coefficient and interpolation. And so I asked you guys to make scatter plots and then to either extrapolate or interpolate. I also asked you to find the correlation coefficient, which hopefully everyone succeeded in doing. But so I want to do this just to kind of A, see what data you found, B, talk about any mistakes you made, because mistakes are good room for growth, and C, reinforce the concepts that we should have learned.
Okay.
So let's maybe you won't have any mistakes, in which case it'll be a complete waste of an exercise. Go for it, Elspeth.
I'm perfect.
Go for it.
So I did on movie length, like the length of the movie versus like worldwide gross of the movie. I don't know. I was interested to see if there's any correlation. And so the data's kind of all over the place. I guess because a lot of it has to do like movies on like how popular they were. If people were interested in the movie itself. And so looking at the correlation coefficient, so there wasn't much of a correlation between them, like there kind of was. And so I was just sort of seeing that like anyone writing a screenplay would sort of, maybe if they knew that if the movie's roughly this long, you could make in some sort of like range of profit. And so just because I did 140 because there wasn't any data for a movie that long, and guessed that there was about, you could make like roughly $752 million if like, if that's worldwide, right? Which is interpolated data.
Good. All right. Thank you. So leave that up there, actually. So one thing, just to be clear on what, it's fine. Just leave it. It's good. It's good. What is gross?
I meant like the.
So I know what you meant, but what is it?
Is it like total profit?
Yeah, like
total
profit.
sales?
Yeah, so I think probably, I would imagine it means like total sales or total revenue or something.
Yeah.
Good. All right, thank you, Elspeth. One last thing to look at with Elspeth. So this was perfectly fine. But just when we think about this, when you go off in life and you actually do make a linear model, like is this data linear? Does it appear to trend linearly?
Not really.
Not really. And sometimes data will and sometimes it will not. But also, I appreciated this scatter plot because it's well formatted. We have two quantitative variables and every point represents what? A movie. But can you...
Oh, these are all 2010 movies.
These are all 2010 movies. It's always important when we're making lines of best fit, like in the future when you're making lines of best fit. Right now in this class we'll probably make a lot of lines of best fit that may be nonsensical just because I want to practice making lines of best fit. But if you're really doing this, like if you're doing some statistical analysis somewhere in life, you should always have like a theoretical model in your mind. And so here, first of all, these are movies, not only are these movies from 2010, what kind of movies are they, clearly? More so than long.
Big budget.
Like these are all pretty successful movies, right? Like if I just made I could make a 2-hour movie. So would my movie
I did
be successful?
like box office movies.
So these are, yeah, like really big box office movies. So that's one thing to keep in mind is that these aren't just any old movie. But why might you expect there to be, or would you expect there to be a positive or a negative relationship? And would you expect it to be linear? Zach?
I would almost expect it to be like a bell curve because the movie's too short. People probably won't want to watch like movie that's like an hour and 15 minutes. Like that's kind of weird length for a movie, I think. And if the movie's too long, people won't want to watch it.
Yeah. So I think that this was really great to investigate, but now upon seeing the data, it kind of makes me think like, you know what? What's the best movie you've ever seen?
It's a tough question.
I don't know, but like, but was it 100 minutes or 120 minutes or 140? Like,
couldn't tell you.
are longer movies better? I don't know. I've probably seen a really good movie that's only 80 minutes. I've probably seen a really terrible movie that's 160 minutes. I've probably seen a really good movie that's 160 minutes. Like the movie doesn't so much, at least to my mind, predict how good that movie and successful that movie's going to be. So keep in mind, like, you do need to think a little bit.
I misspelled length.
As you did misspell like. All right, Toby. All right.
It was a long night.
Yeah?
What is in the
trying to interpolate, but like I didn't know.
Oh yeah, no, the line.
Do you like if I was just gonna ignore those and I
Yeah,
didn't get
so
that.
that's very relevant. What do the E's mean? Right there. The line of best fit is this.
Is that like,
I looked up and said
I was really confused.
is that
Yeah,
scientific?
so good, I'm glad you looked it up. And a couple things, this is fine for you to write now, but I want to make sure you guys understand. Like, instead of y, actually it'd be preferable if you wrote y
Carrot thing.
with a caret thing, yeah, because this equation is not representing real data. This equation is a what beginning with M-O-D-E. Yeah, this equation is a model. Therefore, it's saying the predicted y value is such that it's 7 times 10 to the 6th power times x plus 2 times 10 to the 8th power. So the big E means times 10 to the. Okay. A good question.
Wait, but if it doesn't have a number after, then how do you know what power to raise it?
It's not just going to be like 7e. That's 7e plus 06. 2e plus 08.
I thought that had to say like, I thought there was like, I thought a number came right after the E and that's what you raised.
And that's what it is. It's just saying plus. I mean, if it were minus, it would be like 2,
But how do you know it's 10 to the 6?
because it's 06.
Do you multiply those or you add?
that's
So if I write 7, so I wrote down 7. So instead of e, substitute this e with
Times 10?
times 10 to the, and then this number.
No, alright.
So substitute this e with times 10 to the this number.
Okay,
Okay.
that's just different from
Yeah.
that.
Sometimes you might see a single e, sometimes you might see double e's. But either way, I don't know why it's e. Maybe it stands for exponent or something. Yeah, Kristen.
Those 2 point like numbers, are you multiplying them together?
These ones right here.
Yeah.
Oh yeah, actually, what is that sign? I don't think it's a multiplication sign.
That's supposed to be subtraction.
I think it's a subtraction sign, probably. We can see. I think, yeah, it's a subtraction sign. And so linear models are always of the form, at least that we're going to talk about, y hat equals, basically mx plus b. Some slope and some intercept. In this case, mx minus b. And so what does that imply about a movie that is of 0 minutes long?
Negative.
It would have negative revenue. Or a movie that's
Watch
even,
it and
a
then
movie that's
you
even
add
1 minute long.
that plus one.
A movie that's even 1 minute long, what would be true about a movie that's 1 minute long?
Negative gross.
It would still have negative gross revenue.
You could pay people to watch it.
All right, without further
The one
ado.
that's like really low was like 127 hours. You know?
It just didn't do well. Yeah. Well, it's because it's like, you want to watch it forever and you got a guy that's cutting his own.
I watched it. It was really strange.
All right, so let's give Toby our full attention before we go.
So, I had an idea for a presentation, but it was too real, so I scrapped it.
Alright.
I decided, I was thinking I could just take normal data and make an observation, but instead, I stumbled upon this curious little experiment / fake story where these are, as you see on the y-axis, that's happiness, and on the x is friends. I found this very interesting data set and it's got a plot on that website where it described an arbitrary world where you can count, you can find the number of, you can measure happiness and by how much friends you have. And as you see here, it's very linear. And it makes sense because the more friends you have, the more happiness you get. And that's what I said right here. And the linear coefficient is very strong, proving it. However, what I found that was more interesting is as you increase, this is the opposite situation where it levels off after 6 friends, and after that, it gets into a negative correlation, and that seems strange. Like, actually, bro. So I thought this was a really cool thing that it didn't involve actual real data, but it shows like a very important, like, you could make I wanted to make a story about this, and I had a voiceover, but I lost it. So yeah, but it's a story where someone who has so many friends, and he thinks he's so happy, but the more friends he has, the more it weighs him down, and he ends up being dark at the end of the story. So it's very unfortunate, but that's my presentation. Thank you.
All right, thank you. So this was a bit weird because I would have preferred that you gathered real data, whereas this data looks like it was just presumably made up by some.
I'm gonna take a chance.
I assume that this probably came from some Princeton stats class where they were basically giving a lesson, talking, and had to guess, Princeton.edu/online help. They're probably talking about what we're talking about now, and there's probably some professor at Princeton, much more erudite than I. What does erudite mean?
Scholarly.
Yeah, much more scholarly than me. But they're saying things like, yes, they're saying,
erudite. Is there anyone?
as your friends increase, so does your happiness. And in this case, Toby was unable to find the correlation coefficient because he didn't have the data, which was a problem. But what would you think the correlation coefficient would be here?
1.
I wouldn't say 1, because 1, so that's a good point. If we have a correlation coefficient of 1, that corresponds to basically a perfect linear relationship. This isn't perfect, but Tanner, guess again.
0.9.
0.9. So it's definitely, we know the correlation coefficient has to fall between 1 and -1, but since this is positive and pretty strong, Tanner said, well, it's going to be pretty close to 1. We'll talk about this more later, but is this relationship linear? No, the model that Toby articulated well was that actually maybe
Actually, the name of it was
curvilinear or parabolic or whatever, but it's definitely not linear. So here you could say the model that Toby articulated well is like, oh, you make some friends, you get happy, and then you have too many friends and it stresses you out or something, I guess.
Was the first graph like?
But it wouldn't make sense to model this with a linear trend line. Like, what would a best fit line look like here?
It would cut like straight through.
Yeah, it kind of, maybe you can go like this, but clearly that black line doesn't really represent the relationship. Christine, do you have a question?
Yeah, the first graph, is that just like ideal, like what you expect, and this is like actual?
They're
Because
just
they
two
both have
sides.
equal friends.
They're two different.
I
One
just think,
shows the positivity and one shows the negativity.
I'm pretty sure that this is made up data. Why am I sure it's made up data? Because it's pretty hard to quantify happiness. I would say it's even harder to quantify friends, and hopefully if you're quantifying friends, you're doing, hopefully you have more than 4 friends, right?
Yeah, like what are you counting a friend?
Why
You
does
guys
it
are
go
all
to
my friends.
-2?
I already have
Why does
like
it
11
start
friends
with
in
-2?
here.
Can you really have like enemies?
Alright, Toby, thank you. Alright, Tanner, you go and then.
Okay. Can you open up the? I just sent you another one with the PowerPoint link because I made a correction to it.
Alright, come join us.
Okay, mine,
Alright,
five-area data, it's kind of an obvious one that you could all probably guess the correlation between height versus shoe size. So it's not too much of a shocker that there's a pretty heavy positive correlation. The taller people get, the bigger the foot generally is, the bigger shoe they wear. The trend line had an equation of like 0.23x minus 5.66. So it's a slightly positive slope and a correlation coefficient of 0.62, so a little more close to 1. So as x increases, y increases. And I extrapolated saying someone who's 83 inches tall probably has a shoe size of 14. So it goes a little bit off the chart here, but then I kind of just like guessed that would meet it up there. I'll put it at 14. And my source was StatCrunch.com.
Okay, good. So where did StatCrunch get this data, do you think? Do you know?
They found
We
people.
can click on it.
I used before too. I think like users put their own.
Yeah, I think StatCrunch, I've been to this website before, and I think you're right.